Basically, yeah, I'm very happy that I can be here with you. And I also would like to say hello to people that they are online with us. Yeah, and I thought what I can tell you about this topic, because as Tim said, on every conference, on every training, you are talking about vulnerability and the patch management. And yeah, when I was preparing the presentation, I was thinking what I can share with you, what will be like additional information that will be useful. And I thought, you know, that maybe I will share my experience, my practical point of view after remediating about more than 20,000 flaws in OT environment. And I would like to pass through the theory, but not for purpose to explain you the theory, because all of you know probably this better than me. I will share like how the theory is meeting with the practical point of view. What is like happening when you try to follow this. Okay, next slide. I think that I went to the last one. Who knows how it's going to go forward? Okay, it's agreed. Okay, so the question is patch or not to patch OT systems and daily dilemmas in the risk management and the plant business continuity. I would like to explain you in the end why it's a dilemma, and it's a dilemma of who to take decision if you are patching or you are not patching. Basically, I know the theory. I met long time ago some very well experienced director from the petrochemical plant, and he said to me some very nice theory that if something is working good, it's always you will find somebody that will try to make it better, and in the end you are just looking for the way to back to the place that it was still working. So it's always when you are trying to make something better, it's taking a risk that will not work in the end. First of all, why we have vulnerabilities? Because we have bugs in the program, in the code. When I started my journey on Warsaw University of Technology and we started the programming classes, we were programming with Pascal language. I don't know, probably some of you remember the Pascal language, programming language. Some of you maybe not. But when I started the classes, the professor that came, he said another theory, that code that has more than 2 lines for sure has 1 bug. So it means in Pascal, 2 lines has beginning and end, because in Pascal you have to declare the start of the program and end of the program. Everything if you will put inside there, for sure you will do some mistake. This is like real and true theory. I talked with my brother, he's a programmer, and he's well experienced doing a lot of programs. And he said to me, you know what? I was like few days ago, look at the code. I was like doing the review of the code, and I thought, oh my God, who wrote this code? You know, it's a lot of mistakes, a lot of bugs there, and so on. And in the end, he discovered that it was him a few years ago that did this program. You know, it's like, if you are the programmer, always you are looking to this code that you did. Even on the PLC, you are doing the program. You are looking in the end, and you are thinking, oh my God, what is there? What is there? And after this, you are like thinking, who did this? Yeah, it's me. So yeah, so this is the theory. This is the theory that always, if you are programming, you will do some mistake. Doesn't matter how perfect you are, how many times you will review this program. In the end, if you will back once again and once again, you will find something more and something more. So this is the reason that you will always have vulnerabilities, we'll have always bugs in the programs and so on. And of course, we have to focus not just on the, let's say, SCADA application, operating system, and so on. We have to also look on the firmware on the PLC. We have to also look on the user program on the PLC. Yesterday, yeah, I think it was yesterday, I was on the workshop. I think it was Jeffrey and James that they present ICS vulnerability hunting. And they said, something really important that, yeah, you are focusing on the well-known vulnerabilities, yeah, that it's published and so on, but also you have a user code. And who is looking vulnerabilities inside this? You have to, and as a patch manager, I love them and I hate them after this presentation, because I have a lot of work with well-known vulnerabilities, and they said to me on this workshop, you have to focus on something more yet, yeah? So it's more work. And also they said you have to focus on the mechanical vulnerabilities. I didn't think before that cybersecurity, let's say patch manager, will have to focus on something like this. But it's right. If you will not focus on this, you will have like some, let's say, bugs in your program. But in the end, this will materialize if you have like a mechanical issue and a process issue. So yeah, it's really interesting that we have to focus much more here. So I will give you like some couple of let's say statistics, because yeah, it's important. I use it some report. Then you have the information from where I took this data. This is interesting because since 2014 until 2021, it was like growing so much the number of vulnerabilities. And on the last years, it's still a lot discovering, but they are not growing. And the question is why? Why they are not growing? Maybe because of this effort that we are doing to discover the vulnerabilities, it's like not enough to find more and more and more. Or maybe, but I don't believe on this, the program started to be like good enough that we are not finding more. But I believe that we are not doing too much effort. And what is the important? That in year 2024, and it's almost like if you will go to every report, you will see the same pie, that most of the vulnerabilities, they are high, and a lot of it's critical. This is important because high and especially critical can allow you to take like full control of the SCADA system. So yeah, this is very important, that you have to know that criticality is important. But of course you have to look at your environment, because and your plant, because even if it's a critical vulnerability on the control system, on the SCADA system, or the DCS system, or on some PLC, it's not always mean the same. Because if you have one PLC that is like putting water to the glass, and another PLC that is controlling the, let's say let's say on the emergency shutdown system. So for sure, you will first have to focus on the emergency shutdown system, then on the PLC that is putting water to the glass. Of course, maybe if you are thirsty, it's important to also patch, maybe you have to patch first the glass water PLC. But yeah, you have to put this and match it with your environment. But this is well-known theory. So another thing I wanted to show you, it's a percentage breakdown of vulnerability of the SCADA components in 2024. Basically, most of the vulnerabilities, they are located in the engineering software, SCADA and HMI components, but also the big pie is taking on the PLC, component communication cards that they are installed on PLC, and other industrial components like a big bag. Mainly the vendors, they are like releasing the patches that we are happy that we are receiving them. We are trying to patch as fast as possible. Yeah, some of them, there is no plans to patch, and we have to think what to do with those vulnerabilities. And sometimes patches are not released. This is also the funny story, because when you are doing the vulnerability assessment, you are discovering the patches, you are discovering the vulnerabilities, and the information from the vendor, it's like do some workaround. Yeah. Basically, you are doing big effort to do this workaround, and in the end, they are putting another information that additionally you have to do this and this and this. So we are back into the story that you have to start this once again. So yeah, but what can do? They are doing their work, and it's good that they are doing that they are discovering more what you have to do. Yeah, but it's a really permanent work. Receiving, you are checking what they are digging to. So actually about water, Dominic, you can give me water because yeah, I'm thirsty. So this is this PLC. It's a Dominic. He is this PLC from water. Sorry for that, Dominic. So basically, what I wanted to show you here, it's a trend. Which companies they are, how to say, they are giving them the most advisories. And if you will look on this, those slides, this slide, you will see that every year it's a Siemens on the top. Yeah. And I was thinking, why Siemens is on the top? Why? It's bad, so bad that has a lot of vulnerabilities, and it's not. Why Siemens is on first? It's my opinion. Why it's on first? Because Siemens is well-known company. So everybody that is doing tests, I don't know, they want to attack some like test the OT environment and so on. They know Siemens. You know, Siemens is a global company, very well-known company. Right now, the Schneider Electric is also growing on this position because every conference that I am going, every training, people are talking about the Modbus. Modbus, the origin is from Schneider Electric. Yeah. So now they are starting to attack and checking the Schneider Electric and so on. A little bit, yeah, it's also Rockwell Automation. So basically, it's not if some vendor or some, let's say, product, it's not on the list of the vulnerabilities, it's not mean doesn't have vulnerability. Because if right now, me and Dominic, we will open company and we will develop the PLC, and you will not find this on the vulnerability list, what doesn't mean? That we have perfect PLC? No, it means that nobody checked this, and this is the reason that you don't have vulnerability. So really, you have to think in this way. It's not bad product. It has published a lot of vulnerabilities. It means that they did a lot of effort to find it, and they put a lot of patches, and it's good. It's good because you are like remediating this flaw. So, what is the most dangerous? Which vulnerabilities are most dangerous? This that has like exploit published. Because if you have a vulnerability and don't have an exploit, you need an experienced team to break this vulnerability and pass through. But if it's published exploit, then every kid at home can read the manual how to use an exploit. And of course, if you have like proper for them and not proper for us exposition of this asset. For example, if you will allow this communicate over the internet, they will use this exploit and they can do whatever they want to do. So yeah, and this is also the information like a statistic information about published exploits during the year. So in 2022, it was 555 CVEs that were exploited and had well-known exploits. 2023, it's less. 2024, it's less. So what doesn't mean that these people, that they are well experienced, they are not publish this, or they are selling this on the black market, let's say, because before they published, now they are earning money from it. Yeah, on black market, you can like how they call this like malware as a service and so on. Yeah. So basically, I think that they are not publishing this as much as before. So here it's like information about types of vulnerabilities and say that it's improper input validation on the SCADA and OT system. Yeah, it's true, but yeah. Another is like, so fun, it's like the information missing and encryption of sensitive data. During on the communication between the PLC and the supervisory and control system, like a SCADA application, end-to-end encryption, it's not so common. So it's an obvious vulnerability. Okay, so here's the information that I look at this report, and I thought, is it good or is it not good? Because here you can find the information about the patches. Like I'm from oil and gas, so I will focus on this, that 23% of the companies, they patch frequently, monthly or more often. 67%, they are patching during scheduled maintenance windows, and 10% it's like oh no, sorry, this is this 10%, yeah, that they are patching during the maintenance windows. And I thought about this, that they are patching like frequently, monthly or often. About what kind of patches we are talking, because a lot of people is thinking that patches, it's just a operating system, a Windows, yeah, that you will put the Windows update, you are patching, then you will answer, yeah, I'm patching this every month, you know, we have like a monthly schedule. But what about the vulnerabilities on the firmware of the PLC? I want to see the company who is patching the firmware every month on the ESD system, high integrity pressure protection system, on the DCS, and so on. I want to see this. Really, it depends how we understand what doesn't mean the patch management and what we have to patch. Okay. Vulnerability detection and identification. So on the theory, you have to do the detection and the identification on vulnerability, but how to do this? Basically, they are putting the information that you are not recommended to use the active scanners, and it's true. You cannot do this, but I will tell you one funny story, because me and Dominic, we built like a test environment, quite big, you know, we had like old PLCs like G, Fanuc, 9030, that is very old, we had the DMS PLC, we had a new PLC of the Schneider Electric on Rockwell Automation and the DCS components. It was the purpose to test, to do the red teaming, pen testing, and so on. So we had the Kali Linux there and so on. Yeah. And one day I said to Dominic, let's use the active scanner, like commercial active scanner, and let's do the aggressive scan on this environment. It's a test environment, you can do whatever we want. And yeah, in this day, we had a presentation for the board member, how it looked like the lab and so on. And we turned it on the scanner. We had like a heartbeat there from some components, like the PLCs. This heartbeat was connected to the switch relay. The switch relay was doing like click, 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 click. When we started the scan, the cycle of the PLC started to be longer. They did like click, click, click. After this, back click, 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 click. You know what? In the end, we discovered that the vulnerability scanner killed only one asset, completely killed, that we had to reboot. And guess what was? It was Kali Linux. All the components, they survived this without any problem. Of course, they had like longer cycle, but for a few seconds. And with the Kali Linux, we had a problem even to reboot it, you know? And we had a presentation soon, and I said to Dominic, we are crazy, what we did, you know, we have to present now the cyber attack, and the Kali Linux is not working. Of course, we restored this and it worked, but yeah, it was funny. Another story, We have also the competence centers and the training center, big training center in Gdańsk. It's a great city in Poland. If you will go there, you have to visit Gdańsk. And we were doing the fuzzing. We have different components there, but a lot of automation system and so on, and also Kali Linux. And we still use it a lot of tools to fuzzy those systems without thinking what we are doing. Just click like full scanning, aggressive scanning, and so on and so on. And again, we killed Kali Linux. So I'm not saying that Kali Linux is bad, but it's like not developed to protect itself from the cyber attack. It means that Kali Linux is flying so high that nobody is flying more, so don't have to be like protected. Don't have shield on his back. Yeah, so this is the story about the active scanning. Of course, I don't recommend you to use active scan on the production because this lessons that we did, it was on the test environment, nothing happened, but it's not mean that if you will do this on your production, will not finish on bad way. So basically, of course, it has network IDSs that help you to identify vulnerabilities on your environment. Of course, if you monitor everything, then you have like better posture of vulnerabilities. The problem is that sometimes network IDSs, they don't discover asset correctly. We had a story also that we use it like, we test, I think, 5 network IDSs and collecting all the information about assets and so on. And you know, for some PLCs, they didn't discover them correct. Like, for example, they said that this PLC has firmware version 7.0. We checked it on the vendor side, and the highest firmware version was 4.3, as I remember. So if this based on the database, and it's comparing that you have 7.0 and vulnerabilities are to 3.2, there you say that everything is okay. So yeah, this is automated tools are good, but I think are good only if you know your environment. Because if you don't know your environment, you will connect it and you will get a lot of information. You don't know where is the truth. It's like with this presentation of AI. We don't know if it's cheating, telling the truth. You have to compare this and then check how it's like, where is the truth. The best way, but of course, it's giving a lot of effort to do the asset management process, do the inventory, collect all the information and maintain it. After this, you have all the data. You can build like your own tool to compare vulnerability database that you can download, you can connect online with your assets. This is the best way, but it's giving the highest effort. Okay. So yeah, this is our perfect circle about the vulnerability management, patch management, data collection, monitoring and evaluation, patch testing, patch installation, verification, and reporting. Perfect theory. Yeah, about the data collection, as I said, on theory, you have the data collection. There is no explanation how you have to do this. I said the best for me, it's like make these people that they are administrators to put all this data that you need to do the vulnerability and the patch management. Of course, you are using the automated tools like network IDSs and so on. Sometimes maybe active scanning during the maintenance outage, but don't use Kali Linux on this time. Yeah. After this, you have like a monitoring and evaluation. So if you will find the vulnerability, you are looking if the vendor provide a patch or they provide some information how you have to manage this. You have to check if this patch match to your environment. Yeah, so basically, and you confirm that you can do this safely, because you don't want to patch and after this you will discover that your system is not working. Yeah? So you have to be sure that you can patch, that you can install this patch. And here we have also the funny story, because we had, let's say, some PLC and had a vulnerability. And we check it that has the patch for this kind of PLC. We contact with the vendor and ask it if you can install those patches. In the Polish branch office, they said yes. But we thought it's too much important for us, so we will ask headquarters. So we wrote to the headquarters, if this patch, we can install all this kind of PLC on this application. Yes, you can do this. And we installed this patch. And in the end, the PLC stopped to work. So it's not mean if they are saying that you can patch, for sure you can patch. You have to also always consider that maybe has some, let's say, problem, new problem that they didn't discover, and you can have outage on your installation. So this is risky. Patch testing, this is funny too, because we are doing the patch testing, you know, testing a lot, checking on the test environment. As I said, we build a very big test environment that we can install. We can play every game like red team, blue team, purple team, whatever, doing the fuzzing, installing the patches, and so on. Yeah, so basically we got some patch and we tested this installed, checked that the PLC turn it on, you know, like boot, everything is working correct, and so on. Then after you are rolling this on, let's say, production, and in the end you are discovering after a few times a huge problem. I mean that the PLC, it's like rebooting all the time, and you cannot stop this. It's rebooting all the time. You cannot even stop to change the program. It's turning on and rebooting. And in the end, we did some investigation and we discovered, together with the system vendor, that the problem was that we had a block in the program that was used for the serial communication, and this communication was lost. And after this started to repeat and repeat all the same that killed this PLC. So basically, you are testing, but how much effort you will do to test everything? What you will do, you will, if you have like a small installation that has 5 inputs, 5 outputs, then you are happy, you can test everything. But if you will go to the petrochemical plants, to olefin plants, for example, you have a DCS, huge PLCs that they are taking 1,000 of inputs and 1,000 of outputs. How you will test it? You will just put this firmware, you will turn on the PLC, you will see, it's working. Yeah, it's working, you are patching. But after this, you can discover that the devil is inside details. You know, that this is happening. Yeah, the patch installation, this is something that we talked already, that you cannot do this anytime you wanna. You know, you have to, for the firmware and on the PLC, you need the maintenance windows that you can do this. And you have to also have possibility to restore the system if the patch is not working. On the PLCs, can be a problem because you need like backup PLC sometimes. Like I had this story that was rebooting. After this, we managed this to receive from vendor another PLC that we could use with old firmware. Yes, but they look at this PLC with old firmware about 1 month. Because they didn't have, they were selling review. And we had certified program. Yeah, verification and reporting. Of course, after installing the patch, you are like checking how it's working and how long you will check, I don't know. I think all life, because this can happen after 1 year, 2 years, and so on, that the patch did something, but you need exactly this action that you will discover. Yeah, so now the summary. So to patch or not to patch, and why it's dilemma and of who. So basically, as a patch manager, whatever you will do will be your fault. Because you will patch the system, and this will make outage of the system and the installation. Then the board managers, they are coming and saying, what you did? Yeah, I patched it. But why you didn't test it? I tested, but you didn't test enough. It's your fault. Yeah. Another thing is you are not patching because you say, I will make an outage and so on. And I think that you are maybe a little more safe until will not happen the incident. if the incident will happen and they will break these vulnerabilities, they say, oh, Michal, why you didn't patch it? And I would say, no, I didn't patch because it was the risk. But look what you did. What happened, yeah? So it's always your fault. Whatever you will do, it's your fault. You have to take decision. Nobody will take this decision for you. The board manager will not take. But of course, for me, it will be like a good story to take the board manager, sit with him and say, take decision. And I will see what he will do. I will say all the information that this is the risk to not patch, take decision. They will say, no, you are expert, take decision. Yeah? You are the patch manager, we are paying to you. Yeah. This is this story. Yeah. So basically, as I put here on the summary, you have to follow the standardized approach, but will not protect you against mistakes that you will do. My time is finished. You have to maintain up-to-date register on the SCADA component. This is very important. If you have the information on this, I'm finishing 1 minute. On this workshop that I went, the guy said, you don't have to patch all the time, of course, until it will not happen the incident, because if it happened, then board manager is coming saying you didn't patch. Yeah, but it's very important that you will understand what kind of vulnerabilities you have. You don't have to patch them all the time immediately, but you have to understand what is the risk, what is the exposure of your components. Then you are taking decision what you have to do. This is my story. Thank you.